How do you design a document database? What are the steps that you need to follow? And how is that similar or different from designing a relational database? Let's check this out together in this video. Hello and welcome. My name is Elhelw. I have talked in a previous video about the document database model and how the data is stored as collections of documents, usually JSON documents, and each of these documents represents one entity. And inside the document, you have these fields that have either atomic values or arrays or nested documents and so on and so forth. And we contrasted that to the relational model where data is stored as tables in rows, and then you have different columns or attributes and so on. I will link that video in the description as well as up on the screen here so you can refer to it. We have also talked in the past about database design, but I've only talked about that in the context of relational databases. I have a separate video on that, which I will also link in the description. But today we are going to talk about database design in the context of document databases. This is something that has been requested by several people, so today is the day we're going to talk about that. We'll go through the steps of designing a database, or a document database to be specific, and we'll also note the similarities and differences between these steps and the ones that we have seen for relational databases. So to set the stage, why would you design a database? Maybe you have a customer who has come to you and asked you to design a database because they want to build some application and that application requires a database backend. Or maybe you are building your own application and you want to build a database for that application. So either way, you have someone, whether it's yourself or someone else, who wants to build something, an application, and needs a database to act as the backend for that application. So what are the steps that you need to follow to design that database? The first step, as always in any design problem, is gathering the requirements. You need to understand what the requirements are. What are you trying to do? Why is this database needed? What does the application do? And so on. So this usually requires multiple iterations of asking questions and getting answers and refining questions again and getting more answers and so on. Of course, it's easier if you're the one building the application because you know exactly what you're looking for. It's a little bit harder if you're talking to someone else, especially because customers are usually not tech experts, so they may not know what's possible and what's not, what's feasible, what's not. So they may have either too high of expectations, or sometimes they have too low of expectations that just based on their previous experiences. So it's important to try to ask the right questions and try to iterate over that multiple times until you get the accurate representation of what they're looking to do. Of course, a lot of that is going to be specific to a business domain, whatever the business is where that application exists. But basically what you're trying to do is trying to understand what kind of data you're dealing with. For example, is it e-commerce data, customers and products and billing and stuff like that? Is it, health data, for example, patients and health records? Is it, social media information, users and friends and posts and stuff like that? So yeah, you need to understand what kind of data you're dealing with. That's one thing. What is the relationships between these data? How do these different things relate together? What kind of functionality is needed in that application? What kind of reports is going to generate? What kind of queries it's going to do? What kind of reads and writes? And what's the ratio of reads and writes and all that stuff? Who will be using the application? What kind of users does it have? Is it all just one type of users, or are there different types? If there are different types, do these types get different views of the data? Do they have different permissions? Can they do different operations on the data? So this is all things that you need to understand about the application, because that will guide you in how you design the data. So these are all things that you need to kind of gather in this phase. So let's see just a simple example. Let's say that the application that we're building or that the customer is building is a blog application. So for a blog application, some of the functionality that they need would be, for someone to submit a new article to the blog. So this is a write operation, obviously, because you're adding new data. The kind of information that would be submitted would be the author information as well as the text or the content of the article. And they expect this to happen, let's say, 10 times per day. Another potential operation is someone submitting a comment on an article, right? Again, this is another write operation. Usually this will include the comment text as well as the name of the person who commented. And this would happen, let's say, 1,000 times per day, more than the number of articles. Another operation would be viewing an article. This is obviously like the most important part. This is what blogs are for, because people will read them. Not many people would submit articles or comment, but more people would read the articles. So this is the read operation. This is expected to happen like 1 million times per day. And this involves reading the article ID, the text, as well as the comments on that article. So these are some of the example operations, not necessarily like an exhaustive list. There could be more than that, but just wanted to list that. This is the kind of stuff that you need to get while you're gathering the requirements. Once you've accomplished that, usually the next question would be, okay, what kind of database do I need? Of course, today we're talking about document databases specifically. So I guess why would we choose a document database, right? There are certain things that document databases are really good at. So if your application kind of like, falls under one of those things, then document database might be the more suitable kind of database for you. What are those things? For example, if you need a flexible schema, right? Like what? Let's say you have a user profile management system, something like social media, where users may have some basic amount of information that's the same for everyone, like name, date of birth, email. But then every user may have a different set of additional information. Like someone may put their relationship status, someone may put their work information, someone may put their location or what cities they've lived in, and so on. Not everyone will put that information in there. If you put that in a relational database, you're going to have a lot of like sparse data and like lots of nulls all over the place. So you might want to represent this differently. So having a flexible schema helps with that a lot. So that's an example. If your data is already in like JSON or XML format, like something that is hierarchical by nature or nested by nature. So this lends itself nicely to using a document database for it. If you're building a, let's say like a content management system, right? Like a blog as the example that we've just shown before, something where you store and serve like documents or articles or stuff like that, and these articles or documents may have nested comments, tags, categories, and so on. So again, this might be well suited for a document database. So yeah, these are some of the scenarios where document database might be your best option. So you decided that you're going to use a document database, you have gathered all the requirements. The next step would be identifying the data. So analyzing the requirements that you got and trying to distill them into what kind of data that we're dealing with and how do we represent this data. Before I get into that, there's one thing that I wanted to note. When we talk about document databases or NoSQL databases in general, right? Sometimes people say that, well, document database doesn't have a schema. I see where that is coming from because people are comparing that to relational databases, but I disagree that it does not have a schema. I think it does have some kind of schema. Maybe it's not as explicit and not as fixed as a relational database, for example, but there is some kind of schema. Like you have some high level of understanding of what kind of data that you're dealing with. You don't have to have all the attributes. You don't have to have, all the details that you would find in a relational database, for example, but if you say that there is no schema at all, then you really can't build an application on top of that. Like if you don't know what kind of data you're dealing with, then how can you build something on top of that? So there is a schema, but I would prefer to call it like a flexible schema, an evolving schema. These are all, I would say, more accurate than saying there's no schema. Just want to put that out there. Feel free to disagree. Let me know in the comments what you think. So with that in mind, the first step here, again, you want to identify the data, right? So we don't want to go into the same level of detail that we did in relational databases. So in relational databases, we had to identify all the entities, and then for each entity, we wanted to get all the different attributes and so on. In relational databases, you need that because you need to actually create the tables and define all the columns and the column types and all that. Here, we don't need that. So we don't need to go into that level of detail, but you need a high level view of what kind of entities or what kind of data items that you're dealing with and how those items relate to each other. So again, let's look at the blog example that we have. So one thing we know that we need is something to represent the author or the user, right? This is someone who either reads articles or submits articles or comments on articles. They may have name, email, they might have more information, but we need to know that we have this kind of entity that we need to deal with. Another thing is the article. This is obviously the main part of the blog. It will have a title, it will have the text, that's the actual content of the article, it will have a date, it might have other information, but again, We just need like a rough idea of what it may contain. It may have tags under each article. So a tag would have a name and a URL. Same thing for categories. There might be comments. So each comment would have the text of the comment and the name of the person who posted that comment and so forth. So having that kind of like, knowledge will guide us to how the data would be represented and so on. So with that, we need to create something called a schema map. A schema map, for folks who are familiar with relational databases, is very similar to an ER diagram, except it's not, at the same level of detail, but it's just a representation of these different kinds of data and what the relationships between them look like, including things like, one-to-one, one-to-many, many-to-many relationships and so on. But we don't need, for example, to list all the individual attributes and the primary key and the foreign key and all that stuff that we had in the ER diagram. So for the application that we're talking about, the blog application, it will look something like this. So you have users, articles, comments, tags, and categories, and you have the relationships between them, one-to-many or many-to-many, and so on. And you have some maybe sample attributes or sample data in each of them. You don't have to list everything because again, we're dealing with a flexible schema, right? So some documents may have additional attributes. These are maybe like the most essential ones that you need. All right, so now we understand how these different things relate to each other. The next part is probably the trickiest part, or like the most important part when it comes to designing a document database. How to represent and store the data. In relational databases, we had a normalization phase, right? Like we normalize the data, we try to remove as much duplication as possible, we split data into multiple tables and so on. In document databases, it's slightly different. You don't always normalize. In fact, in most of the cases, you might actually store the denormalized data. In some cases, you might need to normalize. So both options are valid and both options serve different purposes. Let's look at these. So you have normalization, you have denormalization. Usually in the context of document databases, we refer to them as referencing and embedding. The way it's represented, normalization basically, or referencing, means that the data is split across multiple collections with references between them, something similar to foreign keys in relational databases. In embedding, it means that you have nested documents within the same collection. So instead of having a reference to something else, you just embed that data in the same document. For updating, if you're trying to update the reference part or the embedded part, when it's referenced, it means that you only have one instance of that and you have multiple documents pointing at it, so you don't have duplicates. So this means that updates for the reference part are usually very quick and easy. When we're talking about embedding, because that embedded object might be repeated in multiple places, then updating becomes more expensive. We'll talk later about what happens if you want to update both things together, like the outer and whatever is embedded inside it. That's a different story. When we're talking about reading, if you want to read all the information together, when it's embedded, it's faster because again, it's all in the same document. You can retrieve it as a single operation. If it's using referencing, so you have two separate documents, you have to do two separate reads and then do a join, so it becomes more expensive in that case. So this is kind of a high level of what the difference is between normalization or referencing and denormalization/embedding. Let's look at what the data looks like in each of those scenarios. Let's start with embedding, for example. So again, we're talking about our blog example here. So this is what an article would look like. So we have a document representing an article. You can see all the information inside it, the title, the text, the date, and so on. And then you have some nested information. This is the embedded information, right? So you have, for example, here, this is a nested array for the tags. So you have an array, and inside that you have some nested documents, each one representing one of the tags on this article. Same thing for the comments. You have a nested array of comments. Each comment is a document. You have the name of the user who posted the comment, as well as the comment text itself. And then you also have a nested document for the author of that article. All this information is embedded inside the article document directly. What are the pros and cons of this approach? As we have said before, the main advantage here is that you can retrieve all the article information together with its tags, with its comments, with its author. You can get all that in a single operation. You don't need to do any joins, right? So if your application requires reading all that information together, this is something that you can use. The same thing for updates. Like if you want to update all the information of the article together, like if you want to update the article text as well as its tags and the author, you can also do that as a single operation because it's still all part of the same document. On the flip side of that, one issue that you have to deal with is the size limit of the document, right? If you embed all this stuff in the document, obviously the document is going to get bigger. And many systems impose a limit on how big the document can get. For example, MongoDB says that a single document cannot exceed 16 megabytes. So you have to keep that in mind as you're adding information to that document. It might at some point exceed that limit. So if that happens, you need to figure out how else to store your data. The other disadvantage, which is probably like the most important one that people will run into, is duplication. In our example here with the articles and the authors, if the same author writes multiple articles, that author will be repeated in all of them, right? So in that case, let's say if you want to update the author information, let's say you want to update the author's email, so you need to update it in all these instances. So that makes the update process, more expensive. But even more problematic is that if that update, let's say, fails while it's updating, or there is a bug in your application and you end up not updating all the instances, then you end up with inconsistent data. So that's a more dangerous problem. Of course, like if you have things like transactions and ACID and so on, it might help with that, but in the general case, you might deal with inconsistencies. So that's with embedding. Let's go to see what referencing looks like. So for the same example, the same articles and authors, now we're going to split them into two different collections. So we have an authors collection that has one document for each author. And if you notice here, each author will have like an ID field. Normally in something like MongoDB, every collection, every document has this field. We just don't usually show it. I'm showing it here because we actually will talk about it and we'll need it. So you have this underscore ID that has a different unique value for each document. And then you have a separate collection for articles. Again, one document per article. And you have here a reference to that author ID. Instead of putting the author information inside the article document, you're just referring to that article to that author document. The main advantage of that obviously is that we don't have duplication of the author information. If the same author writes multiple articles, the author information is only stored once and you have multiple references to that same document. So if we want to update the author information, you only have to update it in one document. You also have smaller article documents, again, because we don't include all the author information there, we just put the author ID. So the document for the article is smaller. So that helps with the document size limit that we were talking about earlier. It also means that if we need to read that document information without the author, then that read becomes cheaper because you're reading less data, right? So that's another thing to think about. The disadvantages of that is if you do need to get the article and the author information together, then now this becomes more expensive because you're reading from two different collections, you need multiple read operations, and you need to join that data as well. So this becomes more expensive. Other disadvantage is that, let's say you're adding another new article with a new author. In embedding, you'll just add these all together in one document, but now you need to have two write operations, one to the author collection and one to the article collection. So again, this becomes more expensive in this case. So, okay, with that in mind, now we have these two ways of representing things. Which one do we use, right? Generally, I would say in document databases, they lean more towards using embedding, but there are cases where referencing is better. So we'll see where is each of them more applicable. And I'll structure this based on the relationship between the data. So if we look first of all for one-to-one relationships, something like user and address. If you say like a user has a single address and an address usually belongs to just one person. Of course, there are exceptions to that rule, but let's assume that this is the case. So usually in this case, it's preferable to just represent them as an embedded document. So basically embedding the address inside the user. Someone might ask, well, why not embed the user inside the address, right? I mean, you can do that. You could go either way. So you choose whatever makes sense for your application. Like if your application is all about users, if the user is the main thing that you want to look for, then it makes sense for the user to be the top level document and having the address embedded inside that. But if your application is all about addresses, like I don't know if you're working for the city or something and all you care about is a different list of addresses that you have, then address might be the top level document that you care about. So depending on what your application is doing, this is how you organize your data. For one-to-many relationships, this is where where it becomes tricky, because you have multiple ways of representing that. The first way that we have already seen is the embedding. So if we have multiple articles, you can embed the author information inside the article. If the same author writes multiple articles, the same author will be repeated in each of those articles, right? So here you have duplication. If you need to read both the author with the article, then this becomes super easy because it's in the same document. Another possibility is the referencing, which we have also seen. So you could separate the authors into a separate collection and then use the author ID to refer to the author document. So this way you don't have this duplication. You can read the article information by itself. It becomes cheaper, but if you want to read the article with the author, you need to do a join. A third way of organizing the same data is putting the author as the top level document and putting the articles as a nested array, right? Here you don't have duplication, and you also can read the author with the articles in one go. So this is a third way of representing it. But again, this depends on what is the most important thing. What is the first class citizen for your application? Is it the author or the article? If you care about reading separate articles, then it would make sense to have the articles as the top level documents. If you care about the authors and reading all of their articles together, then it might make sense to have the author as the top level document and have the articles embedded inside the author. So different organizations depending on what your application is trying to achieve. If we go to many relationships, again, there's different ways of representing them, but usually we use referencing in this case. So if we're talking about, let's say, a university database where you have students and courses, students can take multiple courses, a course can be taken by multiple students, so we can represent them as two separate collections and one of them can reference the other. So here I chose to put the course reference inside the student collection. So each student, I know which courses they're taking. You could also do it the other way. You could do in each course, you can list which students are taking this course. So again, depending on your application, what the application is trying to do, you choose to organize the data one way or the other. All right, now we're done with understanding the data, figuring out how to represent it and how to store the data. We go to the final part of our design, which is the physical design phase. Physical design is the last step before actually loading the data. And by physical design means that this is where you determine things like indexing, replication, sharding, partitioning, all those physical aspects of the database. For example, you might want to create indexes for the fields that are most queried. Like if you have lots of queries that filter on certain fields, then it might make sense to create indexes on those fields to improve the performance. You might want to look into partitioning, like look at your collection, figure out how to partition the collection, because again, this helps with query performance because you need to, instead of scanning one big collection, you can scan smaller ones. Sharding might be another thing to consider, where you can split your database into multiple shards. This splits it to multiple nodes or multiple servers. Again, it helps with scalability and it helps with performance as well. So these are all things that are considered as part of the physical design. I'm not going to get into the details because these will probably require their own videos, but just know that this is something that you do as the last part of your database design. Once you're done with that, then you load your database, and then the database can become ready for use. You can build your application on top of that and start using it. Once it's used, your job is not done. Then you're in maintenance mode, right? Like you still need to monitor the database, see how things are going, monitor the performance. If you notice that maybe you have new queries that are not performing well, you might need to create new indexes, or maybe drop some of the existing indexes if they're not being used. Maybe also the query pattern has changed, so maybe you need to change how the data is represented to fit how it's being used now. So as we've said in the beginning, right, like the schema can evolve, and if the schema evolves, this is usually a result of new data that you need to store or new query patterns that you need to support. So just keep that in mind. So this basically concludes the database design steps for document databases. Let me summarize what we've talked about today. So we've said that the first step is gathering the requirements. This is the most important and crucial step because that kind of like, builds or is the basis for everything else after that. You need to ask questions, you need to talk to the customer, you need to understand what is the functionality that is required, what kind of business domain that you're working with, because that helps you understand what the data looks like and what is the relationship between the different data items. Once you understand that, you need to kind of like have a mental model of what are the different entities, what are the different data types that we're talking about, how do they connect to each other, one-to-one, one-to-many, many-to-many relationships. Come up with that schema map that illustrates those relationships, and then decide on how you want to represent and how you want to store this data, whether you want to use embedding, whether you want to use referencing, which data is the top level document, which data is the nested document. This all depends on your application or the application that you're trying to build on top of the database. A lot of what goes on in the document databases is informed by the application. It's slightly different from relational databases because the relational databases are usually thought of as their own thing. Like you just think about the data and how the data looks and what the data looks like. But for document databases, because of the denormalized nature of it, it depends a lot on what you need to do with the data. So this is a very important distinction between the two. Once you're done with that step, then you go on to physical design, determine things like replication, indexing, partitioning, and so on. And then you can load your data and start using the database. I hope that was helpful. I know this video has been requested by many people, so if you have any questions or comments, or if anything is not clear, please let me know and I will try to answer this as soon as possible. Otherwise, please hit the like button, subscribe to the channel if you haven't done so already. And with that, thank you so much for watching, and I will see you in the next video.